Okay, we're going to go over the homework for lesson 8.3.3. Okay, and let's start with the first one. Use what you know about the area circumference of a circle to answer the questions below. Show all your work. Leave your answer in terms of pi. So remember, we have two formulas that we learned in the previous lesson. Is that first is area is pi r squared and circumference is 2 pi r. So these are going to be helping us figuring out the answers here. Okay. First one says if the radius of the circle is 14 units, what is its circumference? What is its area? So then for the circumference is 2 pi times 14, which gives us 28 pi units. For the area, be pi r squared, which is 196 pi units. Now, leaving it in terms of pi makes it nice and clean. However, it doesn't really give you a good idea of what the value actually is. So a lot of times when you need to compare and you need to figure out what more of the information, you actually need to multiply out the pi to figure out the approximation. Okay. All right, if the circle has a diameter of 10 units, that means diameter 10 units, that means the radius is 5 units. Okay, then for the circumference, it would be 2 pi times 5, which gives me 10 pi units. And then the area is pi r squared, which is 25 pi square units. Oh, I forgot my square units before. Okay. All right. If the circle has a circumference of 10 pi units, what is its area? So we're going to work backwards to use the circumference to find my radius. All right. So 100 pi equals circumference of 2 pi r. The beauty of having pi on both sides is you can reduce them out, so they're gone. And that way you're left with 100 equals 2r, so r equals 50. Now we're going to use that to find my area. So area is pi r squared, which makes this 2500 pi square units. Okay. If a circle has circumference c, what is its area in terms of c? So now our answers won't have numbers. We're going to use just manipulating our variables to get what we want. So we're going to use circumference to find the radius. So circumference is 2 pi r. What then you need to do is divide it by the 2 pi so you can get r by itself. So r is circumference divided by 2 pi. Now we look at area. Area is pi r squared. So we'll put the circumference back in, the c over 2 pi, because that's my radius. And we're going to clean this up. We have pi times c squared over 4 pi squared, because you just square everything. And then you reduce out the pi on the outside with one of the pi's inside. So really the formula is now c squared over 4 pi. That is your area in terms of circumference, meaning the circumference is in my formula. Okay? All right. In 2000, a share of Jiffy stock, it was worth $20, and then in 2010, it was worth $50. What is the annual multiplier and the annual percent increase? Okay, so first of all, the equation we want to use is y equals a, that's the original amount, b is your multiplier, and t is how much time has passed, right? So what do we know? We know the amount now is $50, so y is 50, and the amount before we started was $20. We started in 2000 and in 2010, so time is 10 years. Okay, so we can plug in everything we know. 50 equals 20 times b to the 10 power. Okay, first thing we want to do is divide it by 20 on both sides, so I can get the numbers to work out nicely. So 50 divided by 20 gives me 2.5 equals b to the 10 power. Now to get rid of that, you take it to the 1/10 power. So 1/10 power. So if you have a scientific calculator, it actually is pretty cool to do. You go 2.5 to the parentheses 1/10 power, right? So you get your b. You're not going to get a nice answer. B is about 1.0959, so 1.096. Now it says annual percent of increase, which means I need to change this answer to a percentage first. So this is really 109.6%. Now remember, this is not the multiplier because your percent of increased from your original 100%. So get rid of the 100%, your increase is really 9.6%. Okay, all right. Next question. Larry started a set of proofs to show that if you know AB is perpendicular to DE. So if AB is perpendicular to DE, what I can do to show that is that it will make 90-degree angle, because that's what perpendicular lines do for me. And then DE is the diameter of circle C. So DE is a diameter, means that this length and this length is the same. Okay. Then the sorry, AF is congruent to FB. So what I'm trying to get is I'm trying to show AF is congruent to FB. What I do know then also is that these, if that is a diameter, that means that's a center, and that means these two are radius as well. So they are radii, so that means they are congruent, okay? All right, one thing is missing in your statement here is that you are missing the fact that DE is a diameter. So I don't know why that's missing, but we'll put that in. Okay, how do we know that AB is perpendicular to DE, and how do we know that DE is a diameter? Well, that's given to us, so given, okay? And then how do we know then that angle AFC and BFC are right angles? I mark that because that was given to me because of the creation of perpendicular lines. Perpendicular lines will create right angles for me. So the definition of perpendicular lines, okay? Now, in my diagram here, how do I know that FC is congruent to FC? Well, it's reflexive property, right? It's the same thing, equally the same thing, so reflexive property. And then we know that AC is congruent to BC because the radii must be equal. So right now I can see I have right triangles and I have a hypotenuse and a leg, so I can prove that these two triangles are congruent, hey, by hypotenuse leg. So what triangles am I talking about? Triangle ACF is congruent to triangle BCF, okay? And then because I already have congruent triangles, therefore I can show that these two sides must be congruent because they are corresponding parts of congruent triangles, therefore they are congruent, okay? All right, match each regular polygon on the left with a statement about its qualities listed on the right. So a regular hexagon has a sum of interior angles to be 720. Because it's a regular hexagon, you take 720 divided by 6, you get your interior angles to be 120. A regular decagon, you can figure out a regular decagon, the area, by cutting it up into triangles, right? That's how we figure out all these polygons. So what happens to the middle central angle there? You take 360 and divide by how many triangles you create. Because it's a decagon, there's 10 triangles, so 360 divided by 10 gives me a central angle of 36 degrees. An equilateral triangle has angle of 60 degrees on the inside. Remember, interior angles and exterior angles are supplementary. So if the inside is 60, what do I need to make 180? I need an exterior angle of 120. Same thing with a square. Square has an interior angle of 90 degrees. The exterior angle must be supplementary. So the exterior angle must be 90 as well. Okay. All right. We're going to read this graph and figure out the how to read it, how to read some of the values that we're being asked of. So f of 1 means when x equals 1, what is my y value? Well, when x equals 1, that's 1 right here. My y value is down here, so that's -3. Okay. Same thing when x equals 0, f of 0. That means when x equals 0, what is my y value? I am at -4. Okay, let's see if we can go backwards. Now it's saying if f of x equals 4, so if y equals 4, what is my x? Well, if y equals 4 is right here. Y equals 4, my x doesn't look like it's on the line. So I can see that it's both positive, a little more than 2, and negative, a little less than 2. So I'm going to say it's about, x is about both positive and negative, about 2.8. I could be wrong, a little bit more than that. It could be a little less, right? All right, next one should be a little bit better. It's a little bit more exact. What if you know your y is 0? What is your x? So on the x-axis, what are your intercepts? Well, both at positive and -2. Okay. All right. Examine a relationship below and find the measures of A, B, C, D. Remember, you can find it in any order and then figure out the relationship, right? So if I'm going to zoom in here, and again, apologies for this being so terrible, but I'm going to assume this is 97 because it's very blurry. All right. So why are they telling me parallel lines, right? Remember, always ask yourself that. Here are parallel lines, and you have two transversals. You have one transversal here, and I see that these are corresponding. Awesome. And I also see another transversal this way. And I see another corresponding here, right? So that's definitely helpful. Okay, so what do I know? I can see that, oh, because of corresponding, A is 97, okay? And I also see that, oh, well, the other corresponding I'll deal with in a minute, but I can see that I have this angle and this angle. They're linear pairs. They're right next to each other. They make a straight line, so they add up to 180. So I take my calculator and go 180, take away the 1, 2, 112, I get 68. So D must be 68. And I see that D and C are alternate interior angles. So C must also equal 68. And this angle must be 68 because of vertical angles. So why do I do that? Because now I can use that to figure out this triangle. And since I have angle A and 68, I can figure out that B angle, right? So 180, take away 97, that's the first angle I have. Take away the 68 degrees I have, I now have my B angle to be 15 degrees. Okay, I'm going to list them and actually explain how I got each one, right? So A is 97 because of corresponding angles. Okay, then I went to D. I said D is 68 degrees because of linear pairs, because it makes a straight line with the next door neighbor. Then C is also 68 degrees because of alternate interior angles. And last but not least, B is 15 degrees because of triangle angle sum. The sum of angles in a triangle must always add up to 180 degrees. Okay. All right. Next one, how many cubes with edge length 1 unit would fit in a cube with edge length 3 units? So it's a little bit trickier to see this, right? Because you got to see it kind of three-dimensionally. If this is a unit of 1, you got to fit 1, 2, 3. And you got to fit 1, 2, 3. You got to fit 1, 2, 3. So you're really fitting a 3 by 3 by 3. So 3 times 3 times 3, you're fitting 27 of them in here, right? So 27 of the small cubes will fit in this really large cube. Okay, all right.